Thank you. Can you hear me? Yeah. So that's not what your Erlang can do for you. So what would this be about? Just start with a definition, what I think we can say an Erlanger is. So we can say that Erlanger is someone who uses and promotes Erlang. So it's these two parts on that. And I assume there are some Erlangers in the room. So this has been asked before, but I see some shuffling of people around. So how many of you are using Erlang and like to do so? Okay, some. How many of you are here because you don't know Erlang and you would like to learn more about that? Just one. Anyway, we have representatives of both groups, so that's good. So what's happening here? Sorry, there. Move it. Okay, my slides don't want to move. Yeah. 1 second, sorry. There. Having some technical problems. Well, hope it works anyway. I need to, it's not synchronized, so I need to keep both in line. So as Erlangers, we like to start Erlang projects, and the other side of that is we also like to convince others that they should do that as well. So if some of you who are in the small group of people that don't know Erlang, ask anyone else from the other group what to do about your next project or how to solve a certain problem, then you probably will see that Erlanger will advise you to use Erlang, will probably beg you to use Erlang, or even threaten you if you don't use Erlang. And he will never talk to you again if you end up using Java or something else. So yeah, it's a bit of an exaggeration, but it's what happens in real life when we are in problem-solving groups. We have some problem to solve, and we are trying to promote the best technology for that. So we are going to be obviously biased towards the good things about Erlang. So there's a list of things that we are always going to mention that probably you know by heart. Erlang is fault tolerant, it's functional, it's distributed, it's scalable, all these goodies. And then we are probably going to be successful convincing people to use it because of that. So, however, I have to do that. Erlang projects may fail eventually. So you may not believe that, but sometimes they do. And this is partly interesting because there is usually much more abundant information about things that go well than things that go wrong. Sorry. So we don't very often see reports about failed projects or things that didn't come out as good as they should. And also, we have a slight bias, so it's difficult to admit that a project has failed. And because of that, even for projects that are not as good as we thought they should, we may come up with special bits of that are good. And those are the ones that we report in conferences, papers, or talks, etc. So from the outside is typically a much brighter image of what's going on in those projects than what actually are inside. So for the purposes of this talk, I want you to consider a failed project some project where we are not comfortable working with. We know that it's delivering much more pain than it should. And we see probably things that we thought should have happened didn't happen. And what happens in those cases when we suggested that we should use Erlang and Erlang fails somehow? Damn it. Oh, no. People would blame us for just suggesting this technology. And what's even worse, they could blame Erlang itself, because we have said things that should happen that didn't happen. So they could claim that Erlang is crappy, as this concrete specific failed project actually proves, which is not fair. And we don't want that to happen. So what can we do about that? Obviously, we know that that just choosing a good language is not good enough, right? There are a number of engineering practices that we have to apply so we can increase our chances of success. And when an Erlang project fails, if you are involved in that Erlang project and you have not yet joined the Erlang detractors group, you will reason about those things, and you will have a little retrospective and think, maybe, yeah, our testing was not strong enough, or the architecture was weak, or we didn't put enough time thinking about that. Or all those issues that make a project fail will come up to the seeing, and we will claim that it's not actually Erlang's fault or any other technology we're using that has failed on us. That is something that we could have done better there. And if this is the case, of course, we can just apply that in the successful case when some Erlang project goes well. It's not only about Erlang, right? So there's a lot of things that we have to consider in a project that have to be done correctly so that we increase the chances of having success there. So what I want to do here in this talk is cover those specific qualities of Erlang that are kind of relevant and that affect the shapes of the projects we run. We have both advantages that we can use, but we need to use to make them reflect as actual benefits. And of course, Erlang has some weaknesses that we need to take care of to avoid them making our projects fail and feed with arguments to those that want to criticize the technology itself. So just to put things in context, just imagine that we are in this situation, that we have an opportunity to start a project in our company. We are in good situations because the company has a problem to solve, and we have enough trust so we can decide what to use there. What's the problem they want to solve? So the problem is that they have a current version of certain software that is a disaster, which is an instance of one of these mythical beasts we call legacy. Right? And we speak about that with mixture of hate and sorrow. The sad part is that every company that has existed for long enough will have at least one of those monsters, like under the roof or in the cellar. But the good part is that at least since legacy is so bad, you can just bash it continuously without being afraid of hurting someone else's feelings. And this is a good way just to convince everyone that this is completely unfixable. And then, of course, you will come up with a better solution for that, which is rebuilding it, because obviously it's written in a vastly inferior language that is not Erlang. It's probably a language that is not even functional. And there we use things like loops, which is something horrible, and mutable values. So mutable sounds like a horror movie. And they have shared states. I don't know how that could work, ever. So because of that, the code ends up being so complicated that it's unreliable and maintainable. And like this picture is something that you see that it works, but when you look at it, it really shouldn't. Right? So you don't know what's going on there. Yeah, people then don't even dare twitching that for correcting white space errors. It's like, stay as it is. It can only go worse. Yeah, also obviously it's super heavy and slow. It's using inferior technology, so it cannot work. The only way to make it work is just buying more expensive hardware and to scale it up, which is painful and obviously has a limit. So, since this is a mess, you have the solution, which is, of course, rebuild it in Erlang. This is going to solve all the problems. First, because Erlang is fault tolerant. So we are not going to have more bugs in production. Supervisors are going to take care of that. So that's one problem solved. That's good. Second, Erlang scales very well. Everyone knows that, so we are going to scale to infinity. Second problem solved. It is functional, obviously. So the code is going to be so clean and neat that adding features is going to take hours, if not minutes. So we have all these nice properties that everyone knows how to use. And then just the icing on the cake, it has hot code loading. So even for maintenance or to upgrade the software, we don't have to take the system down. So we are truly speaking about 100% uptime here. So obviously, that's the solution you want to go. And because of all these reasons, you just create an awesome piece of software, even in less time than you have promised. Everything goes as expected. Your system is rock solid, and it's an amazing piece of engineering. So that's the end of the story, right? Why are you laughing? It's like, how many of you think that this is not likely to happen? Come on, we're using Erlang. Of course, I don't think that this is going to happen. So, yeah, oops. You are probably going to say, like, well, so we are experiencing some life disturbances, production issues, or however you can call bugs. And then those guys are going to come and say, but tell us that Erlang is fault tolerant. So what's going on here? Those are faults. Can happen also that, yeah, we might have a little bit of trouble just handling the expected load for this year. And then the same guys will say, but you tell us that you're going to write this in Erlang because it scales. So what's missing here? And even sometimes it's even possible that you have to say, well, cannot really do that change that fast. So the thing is that the one who wrote that just left, and the code is a little bit messy, and we don't really understand that. And then just it's like, they will come and say, but didn't you write it in Erlang? That's, you lying to us? Told us that it's functional. How come that you cannot read that code? It's functional code. What's going on here? So is anyone here more familiar with the situation than the unicorns and rainbows thing? I'm disappointed. I thought it was only me. Well, yeah. So obviously, we know that Erlang is not a magic wand, right? It's a tool for writing software. Writing software is still hard. It's easier when you choose the right tool, but it's hard. And this sounds very obvious when we say that. I mean, I'm not saying anything new, I hope. The problem is that after repeating and repeating the good things all the time, there are people that kind of end up believing that. Especially the non-technical stakeholders. I have heard that many times from people from business. It's like, no, it's just written in Erlang. It's not going to crash. It's like, yeah, sure. It's good for us that they believe that. But sometimes it affects us as developers as well, because we kind of rely too much on the technology and forget about our good old engineering practices. And this is bad for Erlang itself, because then it creates these situations where people like to think, no, it doesn't really work, it's all lies, which is not. So let's go a bit over the benefits of using Erlang and try to reformulate them in a more credible way, just for us. Don't tell this to the business guys. Keep it in mind. So we said that Erlang is fault tolerant. I guess that we mean here is that Erlang helps building fault tolerant systems. It has tools and concepts that make it easier to reason about fault tolerance. But that doesn't mean that any software written in Erlang is going to be any fault tolerant at all. So for example, you have code written in, for thinking something really horrible, C++, but with a strong focus on fault tolerance, with a group that is a group of engineers that are solid and have been doing that for a while. You compare that to an Erlang project that has been hacked in a weekend by a couple of students that didn't know much about software yet. So it's not going to be a surprise that the C++ software is going to be more robust and fault tolerant than Erlang software, which is something that sounds really striking, but I don't think anyone here would expect otherwise. So the first thing that we heard here is that, well, you can just let it crash, and it will work. because you have supervisors. That's something that's very common to see written and said in conferences. I think that is, I can say that is a lie. Don't throw things at me yet. It's not only that just by letting it crash, it's not going to be fault tolerant. Of course, this is a good principle. It means not being defensive. But it's not the whole story. There is much more that you have to do there. So first of all, it's really true that with Erlang, you can recover a system pretty easily from a failure in a process, but that comes with the precondition that you knew somehow that code path could be failing there, and you knew how to recover that. Sometimes it's easy, sometimes it's not as easy. So if you know a code path that is going to depend on unreliable hardware or unreliable software, or requires input from the outside that can be incorrect, it's pretty easy to write software there that handles that in a little process, and if it crashes, then you have supervisors that will restart it somehow, and maybe you need to do some cleanup. But writing software that is robust and fault-tolerant in general is much, much harder. And that, I think, apart from letting it crash and having supervisors, implies other good practices that are not specific to Erlang, which is isolating features, like having clean APIs, avoiding processes that do too much. Thinking about the supervision trees, well, this is Erlang specific, but you have to get all those things correct so that you have more chances to recover from bugs. Because in that sense, those are problems that you are not really expecting. You may have some intuition where they could come from, but you need to have a clean software structure to be able to recover from most of those cases. It's part of the design, and it doesn't just happen for using Erlang and letting it crash. Because obviously, this boils down that Erlang is not going to design the error strategy for you. It's just a nice, very nice tool to implement it. So properly used, Erlang simplifies this compared to almost any other language, or at least any other language that I know. But it doesn't free you from thinking a bit beforehand, what's the strategy here? So one problem that I very often see is that we somehow started to believe that it's possible to just write the good cases and let it crash everywhere with bad matches, like OK equal blah blah. And then at the later stage, we can just slap error handling on top of that, and then we are going to get fault-tolerant and robust services. At least in my experiences, it doesn't work. Because then you are higher abstraction level, and you don't have information about what happened under the roof. You will have crashes that are all the same, being it bugs, being expected problems, like not having files somewhere, being it problems in a parser. So how can you recover from that? At that point, you will end up like trying to catch too much in order to recover from the things that you know you could recover. You're very likely to start catching also bugs that you didn't know were there and masking them, so they have like weird effects later on in some other code path. They are going to be very difficult to spot and more difficult to debug. And this goes worse and worse, and it ends up with software that is not really fault-tolerant, even though it's written in Erlang. So it just boils down to saying that it's not trivial to design a good application and supervision hierarchy. So we have the tools to do that, but we still need to iterate a bit over them and put quite conscious effort on doing it right if we want those tools to become actual benefits and show the world that Erlang is actually fault-tolerant. So, yeah. Well, and the nasty part of this thing is that I think it's rather difficult to test, which makes it even more difficult to get it wrong. There's much more cases where you can fail than cases where you are correct. So writing the test here is kind of tricky. So you also said that Erlang scales well. And this is a bit, I found it a bit weird when I tried to map it to something I can think is correct and we can use to build on to come to that level. because the closest I found is that Erlang helps to use SMP CPUs efficiently, which is right. We have this nice model where we have isolated processes. We know that those processes run in single cores. We know that the scheduler is somehow fair. And this, with a little bit of effort, of course, but to some extent helps us building algorithms that will utilize a fair number of cores rather easy compared to what we would need to do in other languages, where either the distribution work is either too explicit or too abstract. So this part is, I think, is quite fair to say that it's an Erlang advantage, that inside a SMP CPU, we have a very nice model to utilize all the resources there. However, the problem comes that today, when we talk about the scaling, it's very likely that we are talking about the scaling out. So here, using the resources in a single core, or in a single node, is still very important, of course, but it's not the whole story. And when we are talking about the scaling out, I don't see Erlang specifically playing a big role here. This is more how you design the distributed application, how you make sure that you don't have communication bottlenecks, how you connect everything to a network, how you avoid single points of failure, how you recover from dead nodes, et cetera, et cetera, et cetera. How you make sure that adding more nodes is going to scale close to linearly. All those things you can do with any language you want. It's true that Erlang helps a bit with the transparent distribution, but still, if you just use transparent distribution blindly, you are very likely to end up having communication bottlenecks and messes, like different nodes having too many chatting and things like that. So I think we have gone a bit overboard here, and we have extrapolated the true fact that Erlang scales quite nicely in SMP processors or in multi-core processors to the a bit more difficult to back, at least, fact that Erlang scales nicely out. So the positive thing I can find here is that at least, I think that this is true, the Erlang model, the actor model we use to program Erlang applications and to make better use of SMP processors, is rather similar to at least one of the models we can use to build distributed applications. So distributed applications are just collections of nodes that don't share anything between each other and that communicate sending messages. So basically, we have, if we are used to Erlang, we have the model in our heads. So we have this indirect benefit coming from it. So maybe this is what makes this claim to appear so often among the Erlang strengths. Finally, the functional part. Well, not finally yet, but we have said that Erlang code is clean and concise, more or less, and it's efficient to write. Quite clearly, we mean that helps writing concise and easy to understand code. But this means, of course, that you have to know how to write clean code yourself. And you have to know that anyone that's going to touch the code in the code base knows how to do that. Because there is nothing, or this very few in Erlang that prevent spaghetti. I believe it's quite easy to write spaghetti in Erlang. At least I've seen quite some spaghetti there. So if you don't prevent that, you will have that in your code base. And then it will not be true that Erlang code is clean and easy to read. So this is the obvious claim of the day. The point here is just that the implication goes in that direction. If you know how to write clean code, if you know all the principles that you should apply, then doing it in Erlang is probably easier, well, it's for sure easier than doing that in other languages, like for being to the other extreme, like Perl, C, or Bash. There, you can still apply the principles, but it's much, much, much harder. So Erlang helps a lot here, but sometimes you get the implication reversed, like reading about Erlang benefits out there, and this is not true. and becomes a little bit dangerous, because then some people just believe that they don't need to care just because they are writing the code in Erlang. And there is another point of this aspect is we said that Erlang, well, we say obviously that Erlang code is efficient to write. That's correct. So if you compare it to the languages that are more verbose and more cumbersome, you need to apply obviously fewer effort to get the same amount of features, which is obviously good. Especially at the beginning of the project when you have small overhead. And by overhead, I mean anything else that's not creating features, including meetings, fixing bugs, discussing with bosses or clients, whatever. So the beginning of the project is going to be a significant benefit from using efficient languages like Erlang or any other high-level language that is reasonable. The problem is, and this is probably the most important part of this talk, is that as the project goes through, those overheads are going to be monstrous anyway, no matter what you do. You can just try to make them smaller. And that has very little to do with the language you choose. It's more about the practices you apply in the language, in the project, sorry. So the point here is that these choices, like the language we choose and other technology choices, end up having very little impact if we run a long project and if we don't manage to control this thing here. We will end up like fixing bugs all the time and discussing features and implementing things that we don't need, having people moved around teams because managers or whatever want to do that, or leaving the company and having to hire new people that don't know the software, etc., etc., etc. Then these green things are not going to move. They are going to move a little bit faster with Erlang than with the others. But over the lifespan of the project, they are not going to make a big difference. So the thing is, this is this part where we should focus on once we have done the right choices in technology and made sure that we are using the technology the best way we can. Okay, so finally, hot code loading. This is a bit different compared to the others. It's a killer feature. There's nothing to say about that. However, my point here is that I believe that for most of the projects, the impact about this is fairly low, unless you find a specific scenario to leverage it, like we saw in the keynote. So what do I mean with that? First thing, obviously, comes very handy for debugging. There's no discussion about that. You can even change the code in the production servers. I'm not sure whether that's good or bad, but you can do that. But if you're relying into this to have an application that is always running in a single machine, then you would need to do a shit ton of work on top of that. This is a prerequisite, but you need much more things to make this real. So having an application running in a single machine 24/7 is very, very hard. And it's not only about how you write the application, it's about how you handle the underlying operating system, how you handle migrations between data centers, for example. It's a very, very hard problem to solve. If you want to do that, then hot code loading is obviously a feature that is really, really needed, and there's a strong sell point for Erlang. However, if you manage to not do that, it's often much easier to have a distributed application where you can just take individual nodes down without killing the service layer, obviously. So I guess this is what most people do. And this is what I think. Here in this scenario, hot code loading is still nice because you can use it for debugging or for doing like nice tricks here and there. But it's not actually as relevant as we seem to imply when we mention it among the most relevant benefits out of Erlang, because for this scenario, it's not actually a huge benefit. It's a nice thing to have, but it's not a huge benefit. Okay, so those were my points for the good parts. We obviously need to go through some bad parts. And here The idea is the opposite. Those bad parts are things that we can control. So we can avoid those bad parts that people are going to wave against our decision and prevent them from becoming actual problems. So they are just things that we have to take care about. And actual problems will mean that this red overhead thing grows. So this is the thing that we don't want. The first in my list, and this is not what I often see in lists about in these kind of blog posts or talks that say Erlang sucks. So the first in my Erlang sucks list is dynamic typing. And it's weird that it's not often mentioned. And this is weird for me, because for me, it's the worst offender, the biggest thing that creates overhead in the projects, apart from all the social management things, like how to handle teams and communication. Technically, this is the part of Erlang that causes more trouble, at least for me. And I think here it's not an advantage. I've seen eventually places where they claim that this is here because we want that. Well, at least I don't think so. It's a compromise. So by having a looser type system, it's easier to implement other things in the language, the VM, the compilers, etc. But this means that we are now prone to a class of errors that can be avoided in other languages. So this is not good when you compare Erlang to statically typed languages. Because of this, you have other features that you can use as points to see that Erlang is stronger. But that is where the compromise comes. The actual impact is that as the software matures and the project goes on, if you don't have any measures to control this, then you will find yourself fixing more and more and more bugs that are actually typing errors. Those bugs couldn't be there if Erlang were not dynamic. So that's what I mean that this is a weakness. And also, you may find yourself doing the typing in your head. So you may find yourself trying to understand what a piece of code does, and if you don't have typing information there, then you will need to go deep in the code and try to find out what kind of values a variable could have, or go out from the code trying to understand what kind of values that function needs to handle. And that's mental effort that you wouldn't need to do if you were using other type of languages. So what to do here, at least what I try to do, is try to keep typing in my head while I'm writing Erlang. So not try to think that because of Erlang is dynamic, you can just type whatever you want and you are free from the typing system. Because the types are going to be there, you like it or not. It's just they are invisible. And if you don't handle them, they are going to be crappy and difficult to handle. And this means more than just running dialyzer and having type specs, which you should be doing, of course. It means thinking about having very clean APIs where the types are clear, using robust ADTs. Maybe you need to use documentation or code conventions to make sure that the types are cohesive across your application domain, etc., etc., etc. So in short, it means not forgetting about types just because Erlang is dynamic, and try to prevent that weakness to creep into your code base. This other one is very popular. This is, as opposed to dynamic typing, is very often mentioned that the Erlang tooling is weaker than for more popular languages. And of course, this is an effect just of being fewer people writing libraries and battle testing them. So there is not much we can do here. It's the price for not being mainstream. So that's what we have. First of all, you just need to be aware that library support might be immature or simply missing. And why I'm mentioning this here is that just when you are trying to promote Erlang, you will need to be realistic here and handle the expectations about this as well. Because otherwise you may end up finding yourself implementing some piece of the software that is not really core and having to report that to your stakeholders, being then investors, managers, friends, or whatever. So this is just something that we need to handle and take care of properly. The other more concrete problem is that releasing and packaging in the large is typically painful. It's normally more difficult than people think beforehand. So this usually raises problems later in the project. And it's not by any means an unsolved problem. There are definitely ways of doing so, but it's not very standardized. So it depends quite a lot on the type of project you are running and the release pipeline you end up using. So you just need to know that you may end up trying to figure out a nice way of doing this somewhere in your project. So here I think that the best practice could be like just try to do that very early in the stages of the project, try to start building the automated release pipeline. So you have this push-only thing that everyone wants. And it's a bit easier to do when the software that you want to deploy and the system where you want to deploy to are not very complex. So the beginning of the project is very nice time to do that. And also there you will have more times to iterate over that and perfect it so that when the software and the system you want to deploy are really complex and really awesome, you don't need to care about how to avoid running 5 different scripts and 10 manual interventions every time you want to do a release. Because there's no, up to today, I don't think there is a solution that is agreed to be sort of universal for Erlang here. Okay. This is the other issue that I very often see causing overhead in projects is that the encapsulation model for Erlang is not that great. It's not super horrible, but it's not something that's going to help you specifically designing and keeping the structure of your software. So if you don't put some effort taking care of this, you will end up with very funny messes. So, well, as you know, you just have flat module namespace and public-private encapsulation for functions. This means that we have very little to play with if we want to imply some larger architectural structure in the software we have inside the language. So all that effort has to go outside somehow. And this means that you just need to be serious about your architectural structure and have some sort of control there outside of the language using name conventions or documentation or tools or whatever you want to use to make sure that everyone that touches the code base knows what's an acceptable dependency and what's not an acceptable dependency. Because otherwise you will dream and even maybe implement a first version of this. And then after 3 years, you will end up having that ball of mud, which is really horrible. And it's something that you don't want to show to non-Erlang people when you want to convince them that Erlang is great. On top of that, you may even think of using tools here. And then the good thing about Erlang is that those tools are, I think, are easy to write. The bad part is that there are not that many. So as practical examples, in Klarna, we have one tool that we use to try to enforce some reasonable layering of the software, controlling that we don't have calls from, say, bottom layers to the upper layers or from different applications that are not supposed to depend on each other. That helps a bit. This IOTA application that helps you, well, it lets you declare APIs for Erlang applications and check that other applications don't call anything that is not declared as API. So all those external things that help preserving a better structure of the code will help you to avoid having overhead because of this in the project. So just conclusion is don't think and don't say that Erlang is going to do things for you. So don't say that Erlang is fault tolerant. Well, you can say that to non-Erlang people, that don't say that to yourself. Just say that it's a nice tool that you can use to build awesome fault tolerance, and that's going to be on you, which is better, I think. When you're talking about scalability, just keep in mind that this is about scaling on a single node, where Erlang is going to help a lot. It's going to help a little bit scaling out, but it's a lot about how you design the distributed application. Finally, the code is going to be clean only if you write it clean. that's obvious, but sometimes is understated. And if you put an effort on having clean code, because you can do that in Erlang, ensuring that you have strong fault tolerance because you have tools to do that, and making applications that scale out because you don't have to care much about the design because you already know how to write agent-based systems, and you prevent all the problems coming from dynamic typing, the lack of encapsulation, and you manage to handle the weaknesses in tools, then it's much more likely that your Erlang project will succeed, and you will not end up in this horrible situation where people think that Erlang is crappy, and you know it's not. So that's it. I don't know who we went over time.
So I know it's lunch, so remember to vote if you stick off early, and otherwise it's time for questions. There, I have one.
Thank you. Great talk. Lots of truth there. One thing that I've noticed is I don't know, talking to Erlang developers, I find this, I don't know, aversion against thinking object orientation. What are your comments about that? I mean, we have objects in our code. It's just that we don't have object-oriented language. And
yeah,
what are your reactions on that?
Well, hope no one throws anything at me, but I remember when I started writing Erlang, I was an avid reader of the mailing list. And at that time, they were quite common that every few weeks or every week, they came up a thread about object orientation sucks. And it's like, why Erlang is much better. And that was a bit shocking for me, because before doing that, I had in my mind that, whoa, an Erlang process is the best object that I can implement today with today's tools, which were Erlang or Java. So before getting deep in the community, I had in my head that Erlang was much more clean defining objects than Java, which was supposed to be the object orientation paradigm that you should use. So my comments there is that I think that Erlang, if you manage to mix the good parts about all these paradigms we know, which is object orientation, concurrency, functional programming, and use the right tools, you may end up building stronger software. And for me, in Erlang, it's very easy to think about objects that are processes that communicate sending messages, which maps very nicely to many principles that you can suck from other parts of the industry that don't know anything about Erlang, but they have some valid insights about how to design systems in the LARs and how to build clean APIs and how to handle dependencies. And all those things are typically expressed in objects. And I don't see any reason why not to use all those things in Erlang, because they map very, very well. I would claim that they map to Erlang much nicer than they map to Java, at least. So yeah, that's my comment. I don't know if I answered anything, but was my rant.
Yeah, then I guess we're done with the questions. Thank you again very much, and remember to vote.